I'm going to do a couple of quick basic examples of completing the square. These are unlike the examples I did for my GT geometry class, where we explored some other basic properties of this. But please do reference those videos as well. So what we're going to do, we're just going to simply solve for x. Now, completing the square involves a couple of definitions that we're going to use. One of the definitions is our distributive property, like something like this. And I have b times x plus 3. So our distributive property allows us to do the a plus b times the x plus 3. Now this is going to be hidden in there. The other one, of course, well, there's more than one. A times a is a squared. We're going to use that as well, because if these were the same, I could just write x plus 3 squared or whatever. If that was an x and that was a 3. And there's a few other definitions in there that we're going to use as well, but those are more fundamental. So let's go ahead and get started. First thing I want to do is get my ax plus bx, ax squared plus bx is equal to c. I want the c on the other side. And I also want to make sure that my a turns out to be 1, which it is because it's kind of a gift. So we got x squared minus 10x is equal to 15. This is the part of completing the square. We're going to take my b term, divide by 2, and square it. This allows me to get a perfect square trinomial. So I'm going to take that negative 10, divide by 2, which is 5, and square it. And I got x squared minus 10x. And I'm going to add that number to this side. I have a perfect square trinomial. Well, what I do to one side, I have to do to the other. So I'm going to add the 25 to the other side. This is nothing more in factored form of x minus 5 squared. If you didn't get a perfect square trinomial, you did something wrong. What times what is equal to 25 and gives you negative 10, so on. Now what we're going to do is we're going to solve for x. One of the beautiful things about this is that it's real easy. We're going to use the inverse operation of squaring something by taking the square root on both sides. Don't forget the fundamental theorem of algebra, because what we have is we got to take both roots. Okay? Now I'm going to get rid of that negative 5. And right here, I want to simplify my radicals. In my class, you're required to simplify radicals. So the biggest perfect square that goes into 40 is 4, so that's nothing more than 2 radical 10. This is my answer, my two solutions for this problem. One more example. Here we got a b that is odd. But we do the exact same thing. My leading coefficient, fortunately, is 1. So we're going to just go ahead, get the c to the other side. And I'm going to do my b over 2 squared, which is equal to 25 fourths. All right? So I got x squared plus 5x plus 25 fourths, 25 fourths. Good grief. And I need to add that to my 2 plus 25 fourths. Well, this is just a 2. This is just another way of writing 8 over 2, right? Wait a second, what am I doing? I need to turn this into 4. So I'm going to have a 4 on the bottom, and I'm going to have 8 over 4. Okay? So 8 plus 25 is 33, 33 fourths. I'm going to take the square root. I'm going to factor this. So I'm going to have x plus 5 halves squared, okay, is equal to 33 fourths. Take the square root on both sides. It's equal to plus or minus. I'm going to take the radical on the top and the radical on the bottom. I can clean that bottom one up. Fortunately, it's nice and pretty. So I'm going to have x is equal to negative 5 halves plus or minus radical 33 over 2. And if I wanted to, I could put it under one divisor, but I think I'm all good. Alrighty, I'm going to go ahead and save and get this posted.